Hello guys, this is Daniel. We are going to continue our series blockchain coding for Vypers. This series is about developing smart contracts with Vyper, which is a very neat alternative for those of you that don't feel very at home with JavaScript and Solidity and want a more Pythonic environment to do your Web3 development. And that stack would be Python for everything that is local, and for everything that is in the blockchain, we do Vyper. So today we are going to replicate the guess the number contract that we have in the previous series, and we are going to do it in Vyper. We have here the following idea. The contract should take a secret number upon deployment. The secret number, there's a little word missing there, should be within the range of 0 to 100. It should cost 10 ETH to deploy the contract. Contract should allow people to guess the secret number. Each guess that players make will cost 1 ETH. Whoever makes the right guess will have the balance of the contract transferred to his Ethereum address. That's what it says here. And once the right guess is made, the contract should not allow people to play. So with those requirements in mind, let's start defining what we need to have. So to begin with, we need to have a secret number, and this is going to be a global variable that we're going to define in the body scope of the contract. So we're going to have a secret number, and this is going to be a uint. And uint means unsigned integer, and that means that it's a positive integer. That's what unsigned means. Now, the other thing that we need to keep tabs is the current balance of the contract. So for that, we're going to have a core balance variable here, and that one is also going to be a uint 256. Now, we also need to make sure that the contract only allows people to play when the contract is active. So for that, we're going to define a variable here that's going to be called active, and it's going to be a Boolean. This is the basic structure of the variables, but it's going to be useful for the players to be able to retrieve what is the current balance of the contract to see if it's useful or attractive to play, and whether the contract is active, right? So if the contract is still receiving guesses or it allows people to play. So for that, and to avoid the hassle of having to create our own getter functions, we are going to make these two variables public. So that's going to be the first one, and then this one also is going to be public. So everything's great. Now we need to initialize these variables, and for that we need to have a function that it's going to serve as the constructor of the contract when we deploy it. This constructor function is only called once when the contract is deployed, and then is never called. So that function is going to be external, and it's going to be payable, and it's going to be a name with the init keyword, which is the way that we name the constructor functions in Vyper. Now we are going to add a secret number as the parameter that this constructor will receive, and this is going to be a uint 256. And this function is not going to return anything, so we just leave it like that. We need to begin with be able to initialize the secret number, and for that we refer to that variable as self secret number. It's going to be equal to whatever secret number the deployer of this contract is sending on this parameter. So that's one. And we need to have the balance also initialized. So for the balance, just for convention, we are going to say that is equal to itself, though at this instance is going to be 0 because we are just starting, but it's going to be itself plus whatever value is sent with the contract, so it's going to be message value. We need also to initialize the active variable that we have here, so we're going to call it self active value, and we are going to put it as boolean, so it's going to be initialized to true. So this is the constructor, and let's move to the function that allows us to play. So this function is also going to be external, it's going to be payable, and we are just going to call it play. This play function is going to receive a guest number that's also going to be a uint 256, and is not going to return anything because it's just going to be a logic that runs internally that transfer the balance of the contract in case of a right guess. We are just going to verify what is the actual value of the secret number and whether it is the same as the guess number that is being passed by the player. So we're going to say if guess number equal to self secret number, which is the global variable that we define here, then we're going to trigger a logic that should transfer the balance of the contract to whoever called this function. So for transferring values in Vyper, we use the function send. In this function receives two parameters, so A and B. A is the address that we want to send the ETH, and B is the value. So we are going to send the address of the player that called this function, so that will be message sender, and we are going to send him the balance of the contract at this moment, and that's going to be self balance. And this self balance is something that we didn't declare, but it's something that exists in all contracts. It's referring to their actual balance. After that's done, we need to take care of some housekeeping, right? We need to make sure that the core balance of the contract, the current balance, is reset to 0, and that the self active it's reset to false. This will stop people from playing in the future. But would it? We have not put those checks there, right? So to begin with, in order this check actually works, when someone tries to play this function, we need to have an assertion here. And the prerequisite to continue running this function is that this self-active is equal to true. So we're going to assert a self-active equals true. And if it fails, we're going to say this contract is already void. And then we are going to check more of the logic that we need to implement, and is that the requirement that each guess cost 1 ETH. So also this function, when it's called, should assert that the message value that is sent with this function should be equal to 10 to the 18 way, which is 1 ether. So we have these two assertions here. And then let's go to the constructor. And the constructor also has one assertion that we have to implement, which is that deploying this contract requires to submit 10 ether. So we're going to put message value equals 10 times 10 to the 18. And that 10 to the 18 way is 1 ether, and that times 10, that's 10 ether. So I think we have implemented all the requirements. Let's check. Oh, we have another one here. The secret number should be within the range 0 to 100. We are going to do assert secret number, and this is the one that is sent. It's greater or equal than 0, and here we're going to need parentheses, and then no, and secret number has to be less or equal to 100. And we are going to put the secret number should be within 0 to 100. We have it there, so now let's compile. And it compiles successfully. So now let's deploy the contract. So we're going to have guess a number that deploy. We're going to deploy it with a value of 78 from, and we are going to do from accounts. Let's deploy it from account 0 and with a value of 10 ether. Let's do it again, but now let's remember to close the parentheses. We sent it and we got our transaction back, so that means the contract was properly deployed. Now let's check the balance. So let's do guess number 0, which is the index of the current deployment that we have in memory. And let's call one of the variables that are public. So let's do core balance. And that has the 10 ETH that we have there, but it's in way, so it's a huge number. And let's call the active. And it's true, so the contract is active. Now let's play. So we're going to call play, and we're going to play a wrong guess, which is going to be 79, and we are going to send that one from account number 9. So we're going to do from accounts, account number 9, no, account 1, and we're going to send it with a value of 1 ether. And let's play. We send it back, and then let's go to our Ganache to check what is the balance. So as you can see, we actually have the contract deployed by this address, the address with the index 0, and we play with the wrong address with the wrong number with this address that has a balance of 99 because we waste that opportunity. Now let's make a right guess. So we're going to do it with 78, and we're going to play with the same account here. Now let's go to check our local Ganache, and this guy won the 10 ETH that we used to deploy the contract, and this guy lost. Thank you very much. That was the refactoring of our guess the number smart contract with a little enhancement now that we included, which is to have a range for the secret number. In the following video, we are going to include more enhancements. Right now, this contract is not very useful to building an app because it's a one deal affair, right? It's going to work only once, and then this active is going to be false. Now, it will be more neat if we were able to create several games in the same contract. It will be very neat if the one that is deploying this contract can earn from people that is not only playing but also creating the games. We can allow people to create games using our contract infrastructure, and they will be able to earn if people doesn't make the right guess after a given number of attempts. And whenever the contract, whenever the games in that case trigger a payment, we as the owners of the contract that is providing the infrastructure earn a little bit of ETH. And that's what we are going to be able to do in the next video. We are going to build the contract in a way that we can support that infrastructure. And then we can use that contract as a base for a very simple app. So guys, I hope that you have enjoyed. This is Daniel. Smash that like and follow the Morales channel.